All right. We're I've got a hybrid course, so Branko and I are doing the stuff. Hi, everybody.
Against my will.
Branko has been kidnapped and we're trapped in a basement.
Okay,
I'm holding him for ransom. Dear Branko's parents, what's the Serbian currency?
Euros.
Oh, that's right, because it's in
Montenegro we use euros.
For 1,000 euros, you can have Branko back. Otherwise, he has to do math problems until he dies. All right, so.
Wait, I'm here to save him.
Oh, there's a weasel in the house. Oh, it's a weasel. It's the weasel. Hello, weasel. Hi, Alex. Good to see you. All right, so we're trying to do math here, but it's become a party. All right, so what are we going to do, Bronx? We got to show that y equals 5e to the negative t is the solution. What are we going to do?
Take the derivatives of this.
No, that one we already know is the solution. Take the derivatives of this.
Sorry.
How many derivatives do we need?
2.
How do you know we need 2?
Because this is.
That's it. So y prime is negative 5e to the negative t, and y double prime is 5e to the negative t. Isn't that weird? Can you take it from there and show how those things satisfy the equation? Can you pop those into those places?
Of course. So we have 5e to the negative t plus, or because this is a minus.
Good.
So minus 5e.
Oh, times 4. Because there's a 4y prime. So make
Sorry
it minus 20.
Sorry for that. Minus 20e to
Negative t.
Okay. And plus
3 times 5.
3 times 5, that's 15. E to the negative t.
And everybody can see those are all going to cancel out and give 0. So that's it. That's all you have to write. Next one, we're going to show why this one isn't a solution. Branko, how are we going to do it?
The double.
Yeah, you got to do a product rule. Derivative of t is 1, e to the negative t. Then it's going to be minus t, e to the minus t, because the derivative of the power comes down. Then y double prime. Now I just get negative e to the negative t. And then I'm going to get negative e to the negative t again. And then I'm going to get a plus t, e to the negative t. And now I have to do y double prime. So this is negative 2 e to the negative t. Oops. Plus t e to the negative t. Plus 4 times the second thing. And that's the e to the negative t minus t e to the negative t. And then plus 3 times the original t e to the negative t. So let's see what this turns out to be. Who gets killed?
I don't see anybody. Wait.
Let's use another color. Grab another color. I see that the t e to the negative t's all cancel out. Because look, I got 4 of them with a minus sign. I got a positive 3 and a positive 1. So all of these dudes cancel out. And all that's left is 4e to the negative t minus 2e to the negative t. That's minus 2e to the negative t, which is not 0. That's all I care about. It's not 0. I'm supposed to get 0. And I don't get it. So that's not t e to the negative t doesn't satisfy. All right. So another one. Geez, this is one thing you can do is take the derivative and show it satisfies. And what's the derivative going to be? Y prime. Go ahead, do y prime right there.
Oh, hold on.
You take your sweet time. I'm going to start setting up for the next one.
Y prime is rid of the first one times the second one, so that'll just be e to 3t, right?
Well, the 3 comes down and multiplies, though, derivative of the power. So you're going to get a 15. The first derivative is going to be 15.
15 e to the 3t.
Yep.
Right?
And what's 3 times y?
Plus.
Nope. There's no plus sign in the equation.
Wait,
the equation is dy dt equals 3y. So y prime is the left-hand side.
Okay.
15e to 3t. What's the right-hand side? 3 times y.
So I'm confused.
This is dy dt. This
Right.
here is dy dt.
Right.
That's this. Now what's that? We want it to be 15e to the 3t. What's y?
Y is
It's right there. 5e to the 3t. What's 3 times 5e to the 3t?
15.
Yeah, that's all you got to write. 3 times 5.
So it just equals this thing.
Well, write it 3 times 5. How about that? 3 times 5 e to the 3t. And we're happy. The two sides are the same.
Okay.
That's a pretty childishly easy problem.
Yeah.
Can you get that rag over there for erasing I'm going to talk about the next problem out loud. Yeah, you can erase.
All of it?
Yeah, go for it. The next one is dp dt equals p times 50 minus p. That's a logistic. So let's it says here, write a story about a population of animals which fits the logistic differential equation. Given a correct answer, uses coarse vocabulary correctly. Let us tell the story out loud. And every time that we use a coarse vocabulary word, we will make a fuss. Okay? We have, I'll write the equation. That's all we really have to do. dp dt equals p times 50 minus p. Okay? Give me the carrying capacity of this animal population. 50 is right. Does this animal population have sexual or asexual reproduction? Can you have just one of these and they reproduce? So is it like an amoeba, or is it like rhinos where you got to have two males and a female? What do we got? No, we don't need two. Look, P equals 0 is the other equilibrium. So if you have P equals 1, you have 1 times 49. Your population is growing even if you have 1. So whatever this population is, it's like amoebas, it's like bacteria. Even if you just have one of them in a petri dish, you'll get more.
Wow.
So it's asexual. So y equals 50, carrying capacity and an equilibrium, or sorry, P equals 50, and P equals 0 is an equilibrium, because if you have 0 of these animals, well, you aren't going to get any. And that's the story. So it's an asexual animal that reproduces even if you only have 1, but wherever it lives, 50 is the carrying capacity. If you go above 50, the population comes down. It's not a great story, but there it is.
What's a coarse vocabulary in that?
We used carrying capacity, we used equilibrium, and we had two different equilibria. Yep. And we used all those words correctly. All right, let's do number 4. Number 4 is an actual problem. We have dy dt minus y over t equals t, and y of 1 equals 3. All right, how do we solve this thing? I know how. Call on me. It's first order linear. It's not separable.
No, it's not.
So I'm going to notice that p is negative 1 over t. I'm going to notice that q is just plain t. So y is equal to the integral of e to the negative integral 1 over t dt times q, which is just t dt, plus c all over e to that same negative 1 over t dt integral. What is the integral of 1 over t? It's natural log. So I'm going to have this thing happen twice. E to the negative 1 over t dt is actually e to the negative natural log of t, which is e to the natural log of 1 over t, because you use that negative 1 as a power on t. And now the e to the natural logs cancel out. This whole thing just is 1 over t for both of these spots. Is that good or bad?
Great.
Let's use the eraser.
It is.
We're going to replace each of those e blobs. No, just right here. Replace each of those e blobs. No, just the e blobs. This and that. Just the e blobs. The whole e thing. Good. And that one. They're going to be 1 over t. My life just got easier. So my integral, my top integral is just the integral of 1, which is going to be t. And then I'm dividing by 1 over t. So this whole thing becomes t, that's this t, times the integral of 1 dt is t plus c. So I get t squared plus ct equals y. We're not done yet. What do we got to do?
We have to use the initial condition.
We didn't use the initial condition, y of 1 equals 3. Do you want to take it?
I can.
Go for it.
So 3 equals 1 plus c. C equals 2. That's right?
I'm just bringing the weasel
Oh,
into the picture.
okay, hold on. Yeah.
When we start weasel, let's see. C equals 2 is, I think, right.
Is it?
T. So what's the final answer?
So final answer is y equals t squared plus 2t.
Correct. Perfect answer. We're down to the last problem already. Can you erase the top half of the board? I'm going to talk about the last problem. Give a bifurcation diagram for y prime equals a y plus y cubed. So to do this, you got to know the first thing you're going to draw is a horizontal axis that we're going to label A.
You got enough?
Yeah, it's plenty. I'm going to label the vertical axis Y, but it's actually only equilibria of Y. All right, so let's make a real quick table here. A equals and Y. When A equals 1, 0, and -1, that'll be enough. Those are the situations we care about. All right, oh, I didn't write down the equation. The equation itself is y prime equals ay plus y cubed, which I'm going to rewrite as, I'm going to factor out a y, that's a plus y squared. So when a is 0, the only equilibrium we get is 0, and you graph that right there. But you notice no matter what a is, this y right here gives me y equals 0 as a solution always. So my equilibrium, let me switch that black marker. Where'd it go? I see it. I see it. All right. I've got y equals 0 because of this factor of y as an equilibrium all the way, not just the origin. Now, I need some more information. When a is 1, 1 plus y squared is never 0. Remember?
Right.
So the only equilibrium for the positive a's is that part. But when a is -1, I get -1 plus y squared. Y is equal to plus or minus 1 and 0. So I've got this. And because it's a y squared, I know it's going to be a sideways parabola shape for my bifurcation diagram. If you don't know what shape to draw for that pitchfork, do some more points. But look, it's always going to be the a goes right there, and it's up against y squared. So if you have -9, y is plus or minus 3. So a is nice when it's a square. Then you get integers for y, which means it's a sideways parabola. It's not a V shape sideways. It's a parabola shape because of the way the numbers work out. And that's all I'm going to ask about. Any questions from you, Brock?
No, sir.
Okay, I'm going to be doing one more video on my own later, and that's as entertaining as it gets.